So by the end of this lesson, you will be able to determine whether a function is increasing or decreasing at a certain point. And what I mean by that, just to make sure that I'm being clear here, let's say that we've got a function that looks like this. Right? If I were to give you this function and say, looking at this function, is this function increasing or decreasing at this value, at a? Now, the answer is that it's increasing. And the reason is, if you sort of look at the function, at this value, it's going upward. Now, some people might say, well, I think it's going downward. Fair enough. When we talk about a function being increasing or decreasing, we always talk about as the function moves from left to right. In other words, as the x values progress along, are the y values increasing or are they decreasing? So at a, so we can see like at a, our function is increasing. Right? What about back here at b? Let me use a different color here. What about at this value here, b? Well, if we follow b up to the function, at that point right there we can see this function is moving downward as I move from left to right. So at x equals b, we can see that our function is decreasing. Right? So when I say a function is increasing or decreasing, that's what I'm referring to. I might mention while I'm here, there are 2 points on here that are sort of interesting, and that's this point right here at the bottom and this point up here at the top. At those 2 points, the function is neither increasing nor decreasing, and I don't think I'm going to talk about that in this video. I may get there. We'll see what happens as we move along. But increasing and decreasing are always things we talk about as the function moves from left to right. So the question is, yay, if you have a picture, it's not that hard. You're just like, look, the roller coaster is going uphill. Yay, it's going downhill. It's not that hard to tell. It's more challenging if we don't have a graph, and that's what this lesson's really about. So let's move on and talk about that. If all you have is the function, if all somebody told you was what f of x was equal to, then it's really going to be the derivative that's going to tell us whether a function is increasing or decreasing. And these 2 sentences that I have here basically sum up the whole thing. The short of it is, if the derivative is positive, then the function is increasing. If the derivative is negative, then the function is decreasing. It's as simple as that. The basic reasoning for why this is the fact that, remember that the derivative tells us about slope. If the slope is positive, that means the function is increasing. If the slope is negative, that means the function is decreasing as we move past it. So if a question asks you, hey, is a function increasing or decreasing? It just means take the derivative, plug in the number. If the number is positive, it's increasing. If it's negative, it's decreasing. I've got an example or 2 of this lined up, so let's take a look at those. So my first example here, given that our function is f of x equals x squared minus 5, determine if f of x is increasing or decreasing at x equals 3. So using what I said above, we start with a function. We know f of x is x squared minus 5. That means the derivative is 2x. And so, yay, that's the derivative. No, that's not slope, that's the derivative. Now, they wanted to know about x equals 3. Great. We'll now look at what is f prime of 3. F prime of 3 is 2 times 3, which is 6. Because 6 is positive, our function, f of x, is increasing at x equals 3. And we can sort of quickly confirm that because it's not like this one's difficult to graph. X squared minus 5 looks like this. It's a parabola. And so when you're over here at x equals 3, we can clearly see that this function is increasing at that value. So that one we could have done without all this fancy calculus, but I wanted us to have a nice easy example. Let's look at another one. So for this one, we're using our calculator. Sorry, that disappeared. So use your calculator to determine if the function x squared times the sine of x cubed is increasing or decreasing at x equals negative 4. In the second video in tonight's sequence is going to talk more about how to do this. But I think I've actually shown you guys how to use the calculator to do derivatives. So if you remember, the short of it is I just need to tell the calculator to take the derivative of this thing at this value. And again, I'll actually have the walkthrough of how to do this in the second video, but in case all you need are the basics, if you hit math, 8 on your calculator, it'll bring up this. It'll say, you know, the derivative at what value of what function, you know, for x equals what thing. It'll sort of give you these blanks. And we just need to tell it, hey, I want to take the derivative with respect to x. And what I'm actually going to do is I'm going to put y1 in here, because before I start the problem, I'm going to put this into my y equals. And then down here, we'll just say that we need to use an x value of -4. So if we punch that into the calculator, I'm going to pause and punch that in and see what we get. So when I threw that into the calculator, I found out that this derivative was 308.174. And remember from what I said before, it really doesn't matter how positive or negative this is. All that matters is because this is positive, we know that our function, f of x, is increasing at our value, x equals -4. Right. So there's a couple problems in the homework tonight that ask you to find out if a function is increasing or decreasing using the calculator, and the key is use Math 8. If you use Math 8, you'll be fine. Okay. I've got one more segment here to look at in our lesson. And that last segment is, so what happens if our derivative is 0 or undefined? What happens if when I plug in that value, it's not positive and it's not negative? And the short of it, I'm going to talk more about this in tomorrow's lessons, but the short of it is, if this happens, then our function, then f of x, has a critical number at x equals a. So this concept of a critical number is going to end up being pretty huge in this chapter. So all I'm really going to say right now is that if you've got a derivative that ends up being 0 or undefined, you've got a critical number there. So some of your questions tonight in the homework are going to say, hey, here's a function, find the critical numbers. And all it means is take the derivative and set it equal to 0, and find out the x values that cause that. So I think I've got an example here lined up for us. Yep, here we go. I want us to find the critical numbers of this function. So I've got f of x equals x cubed over x minus 3. Finding the critical numbers means I need to take the derivative. So hopefully you remember your quotient rule. In fact, I'd recommend you pause the video and make sure you can do this on your own. And there's a rhyme if that helps you to remember. So we've got low d high minus high d low. The derivative of x minus 3 is 1. Square the bottom, and away we go, or come at me bro, or row, whatever you want, as long as it rhymes with low. So square the bottom. Don't forget to square the bottom part of the rhyme. Great. Now we simplify this thing. F prime of x is, so distributing this thing in, this is 3x cubed minus 9x squared minus x cubed all over x minus 3 squared. So f prime of x is, this is now 2x squared minus, 2x cubed minus 9x squared all over x minus 3 squared. And I want to know where this is 0 or undefined. And I don't know if I made a big enough deal of that at the beginning of this slide. Critical numbers happen where the derivative is 0 or undefined. So when is this thing equal to 0? This thing is equal to 0 precisely when the numerator, 2x cubed minus 9x squared, is equal to 0. Right? It's undefined when the denominator is equal to 0. So when x minus 3 squared is equal to 0. Both of these equations are going to give me critical numbers. So I can factor the left one. That's x squared times 2x minus 9 equals 0. And that's going to give me x equals 0 as one critical number, and x equals 9 halves as the other critical number. And then on the other side, if I square root both sides, I'll get x minus 3 equals 0, and finally x equals 3. So these three things are my critical numbers. At the moment, that doesn't mean anything. I'm going to talk in tomorrow's lesson about what those things mean. For tonight's purposes, I just want us to have some practice with computing and finding those critical numbers. It is possible to use the calculator to find these critical numbers, and I am going to be covering that in the second video. So make sure you check that out. So I will see you there.